Assalamu alaikum. Today we are gonna start the first chapter of further pure one, known as the roots of polynomial equations. In today's lecture, I would focus on the introductory point stated in the further math student 20 syllabus that we have to observe and apply the relation between the roots of a polynomial excuse me, the roots of a polynomial and its coefficients. I would be starting with the basic case of a quadratic equation, that is a polynomial equation with degree 2. Quadratic equation is a polynomial equation with degree 2. So we would be starting from scratch. So we would be now observing the quadratic equations with the basic form x square plus bx plus c. In the next video, I would be remarking on the relations between the roots of a quadratic equation of a form ax square plus bx plus c. Next video. It would be remarked upon in the next video. Right now we are focusing on this part of the equation to simplify matters. Now we have to observe and apply the relation between the roots of a quadratic equations and its coefficients. Now, towards the level of further maths, what is actually assessed? You have to find the sum of roots and the product of roots and apply them. Sometimes the analysis is also required that whether the roots are complex or real. So that would be remarked upon later. But in simple cases, the complex roots are those where the roots are not real. For that, what prior knowledge would be required? The prior knowledge that would be required would be the complex numbers, and the fundamental theorem of algebra. The reason is that the complex numbers are linked with polynomials. When the discriminant is lesser than 0, the roots are complex. Now, for the equation with the real coefficients, for example x square plus 2x plus 5, where b square minus 4ac is less than 0. In this case, the b square minus 4ac is less than 0. So we would deduce that the roots would occur in conjugate pairs. Now we would be applying this concept later in this lecture. For the time being, it is clear to observe the previous concepts learned in A-level maths and in O-level ad maths. Now towards the topic. If we expand the equation x minus alpha multiplied by x minus beta, what would we get? X square minus alpha x minus beta x, and we would multiply negative alpha and negative beta, so we would get plus alpha beta is equals to 0. Okay, and above that I would write that the roots of the equation are x is equal to alpha or beta. An equation is of the form x square plus bx plus c is equals to 0. So simplifying it, it would become x square minus alpha plus beta x plus alpha beta is equals to 0. Now what do we observe in this equation? Comparing the coefficients, we can observe that the coefficient of x, that is b, is equals to negative whole alpha plus beta. So therefore alpha plus beta is equals to negative coefficient of x. So what does that mean? That the sum of roots is equals to negative coefficient of x. Next, if we compare the constant in this equation and in this equation, we would observe that c is equals to alpha beta. So hence it is deduced that the product of roots is equals to the constant for the basic form x square plus bx plus c. Now let's see that what happens if we solve the equation and obtain the roots. Would they be equals to negative b? Would they be equal to negative c? Let's see. We have x square minus 2x minus 3 equals 0. Now I would be factorizing it, skipping the steps of factorization. You had learned it in O-level maths, so it's useless to repeat it. We obtain x minus 3, x plus 1 equals 0. So we obtain x equals 3 or x equals 1 minus 1. Now our sum of roots is equals to negative b. Now inputting the values in both of the left hand and right hand side, we obtain 3 plus minus 1 and negative of negative 2. So what do we obtain? 2 is equals to 2. Left hand side is equal to right hand side. Now towards calculating the product of roots. The product of roots is equal to the constant. Now inputting the values in the left hand and the right hand side, we get 3 into minus 1, and on the right hand side we get minus 3. So we get negative 3 on both sides. That means left hand side is equals to right hand side. So that's the basic working of this theorem. And in simple words, I am continuing the concept in the next page. We have x square minus alpha plus beta x plus alpha beta is equals to 0. We have x square minus sum of roots x plus product of roots equals 0. That's the basic form of an equation, and that remarks the relation between the coefficients in the polynomial in the quadratic equation and the roots of the quadratic equation. The roots are linked with the the roots are linked with the coefficients of this quadratic equation. Now towards the algebraic approach, what sorts of questions are asked in the exam? Now let me remark you. First of all, we observe question number 1. Let alpha and beta be the roots of the quadratic equation uh, x square plus 2x plus 5 equals 0. Okay, part A, part 1. We need to calculate part 1 alpha plus beta, part 2 alpha beta, part 3 alpha square plus beta square. Hence prove that the equation have complex roots. Now we can also prove the complex roots with the help of the discriminant, but it's written here hence. So we would have to observe the roots of the polynomials in order to prove that the equation have complex roots. Now moving forward with the solution, we have A part 1 alpha plus beta, that's equals to -2. Now moving towards the product of roots, that's exactly equals to the constant. So we have alpha plus beta is equals to -5. Now the third part, there are two ways to complete the third part. The first method and the second method. Now we would be observing the first method. We are squaring alpha plus beta to the power of 4. We are squaring alpha plus beta. So we obtain alpha square plus 2 alpha beta plus beta square. Rearranging the equation, we obtain alpha square plus beta square plus 2 alpha beta. Now we have alpha plus beta and we have alpha beta. So we can input the alpha plus beta into this part and alpha beta into this part. So inputting the values, we obtain -2 square is equal to alpha square plus beta square plus 2 multiplied by 5. So therefore alpha square plus beta square is equals to 4 minus 10 is equals to -6. So alpha square plus beta square is equals to -6. Now towards the second method. We have let me write the quadratic equation again in order to prevent confusion, because it's on the previous page and I'm using the next page. So let me write the quadratic equation. So now this equation would hold true for both alpha and beta. So I would substitute x is equal to alpha in the first part, alpha square plus 2 alpha plus 5 is equal to 0, because this equation holds true for x is equal to alpha. Now since this equation also holds true for x is equal to beta, so we would write beta square plus 2 beta plus 5 equals 0. Now adding them, we would obtain alpha plus beta whole square, alpha square plus beta square, sorry, plus 2 alpha plus beta plus 10 equals 0. We would add both of these equations. Now we have alpha plus beta is equals to negative 2. So we would write alpha plus beta whole square plus 2 multiplied by negative 2 plus 10 is equals to 0. Alpha plus beta whole square, alpha square plus beta square whole plus 6 equals 0. Alpha square plus beta square is equals minus 6. Now our second part was that hence proof that the equation have complex roots. The answer is simple. Since the equations, since when the roots are complex and the coefficients are real, they occur in conjugate pairs. So we could not say that either of the alpha or beta have complex values. We say that both alpha and beta are complex. The reason, because the sum of their squares is equals to minus 6. The sum of their squares is equal to minus 6. And it is only case with the real constants that sum of their squares is positive. The sum of the squares of the real constant is always positive. If the sum of the roots is negative, if the sum of the square of the roots is negative, it is crystal clear that the values of alpha and beta are complex. So we would provide the explanation in the third part. We would write part B. Since the sum of the squares of roots is negative, since the sum of the squares of the roots is negative, hence the roots are complex. So these are the introductory types of questions that are asked in the exam. The theorem, now we would be remembering the name. I've told you the application, now we would be learning the name. This formula is known as Vieta's formula. And the theorem that sum of roots is equals to negative b and the product of roots is equals to the constant, that's known as Vieta's theorem. So thank you very much for watching the video. I hope that the introductory part of the roots of the polynomial will be clear to the viewers and the listeners. Thank you very much.